Capsaicin is a phenolic compound found in the placental tissues of chilies and other hot peppers that contributes to the pungency and flavor. When ingested, it is found to promote pain relief as well as have gastrointestinal and cardiovascular effects. Studies have found that it has bactericidal effects when tested against H. pylori and nor A overproducing S. aureus, with the latter exhibiting bacteriostatic effects in addition to synergy with antibiotics such as ciprofloxacin. The objective of this experiment was to extract capsaicin from jalapeno, red Thai, Scotch bonnet, and Carolina reapers, using two extraction techniques, of which one extract was then tested against E. coli, S. aureus, and P. aeruginosa. It was hypothesized that the capsaicin would exhibit antimicrobial and synergistic effects when combined with gentamicin. The first extraction technique used was ultrasound-assisted extraction using a sonicated water bath and 100% methanol as the solvent. The second technique was supercritical fluid extraction, which used a combination of dynamic and static durations, 100% methanol as a co-solvent, and a pressure of 150 bar. Solid phase extraction was performed on all extracts, which were then analyzed via UPLC. The highest yield of capsaicin found was chosen for the antimicrobial investigation. Investigations into the antimicrobial effects started with a minimum inhibitory concentration performed on the pre- and post-SBE capsaicin, which was compared to a methanol control corresponding to the amount in each tested concentration of capsaicin. Based on the results of the first MIC determination, a second was performed using pre-SBE capsaicin that was diluted to have a low methanol concentration and compared against a negative control of 1x PBS. The top three capsaicin concentrations from this second MIC plate were streaked onto agar plates to visualize the most bactericidal concentration. Synergy testing was performed using a checkerboard analysis that consisted of a vertical serial dilution of gentamicin combined with a horizontal serial dilution of capsaicin. Disc diffusion was then performed using a low and high concentration of capsaicin, two positive controls of gentamicin, a negative control, two antagonistic treatments, and two synergy treatments. Extraction results found jalapeno peppers to have the lowest amount of capsaicin at 0.255 milligrams per gram when using ultrasound-assisted extraction and 0.259 milligrams per gram using supercritical fluid extraction. Carolina reapers had the highest concentration at 2.72 milligrams per gram when using ultrasound-assisted and 6.4 milligrams per gram when using supercritical fluid. There was no statistical analysis performed as only one extraction was performed per technique, but there was a general trend that supercritical fluid extraction was the more efficient technique. Bacterial results show E. coli in reds, S. aureus in greens, and P. aeruginosa in purple. The first MIC determination showed some significance in each bacteria type. However, the most likely cause of inhibition in the higher capsaicin concentrations was the methanol. There wasn't much difference between the pre- and post-SBE capsaicin, though in some cases, such as in P. aeruginosa, there seemed to be more of an effect in the pre-SBE samples, suggesting that there is something else in the capsaicin extract that is affecting the bacteria. The second MIC determination found significance when compared to the negative control in the top three capsaicin concentrations across all three bacteria. Some significance was also found in E. coli and S. aureus at mid-range to lower doses, suggesting that the capsaicin was helping the bacteria to grow. These results were also visualized with the MBC, though minimal changes occurred in between doses for E. coli. S. aureus and P. aeruginosa both showed inhibition at the highest capsaicin concentration, which decreased as the capsaicin concentration did. Synergy results were depicted as heat maps, with the darker color indicating more bacterial growth. Column 1 contained only a serial dilution of gentamicin, while row H contained only a serial dilution of capsaicin. Based on these results, two synergy treatments were chosen specific to each bacteria, in addition to two treatments that were considered antagonistic or indifferent in effect, which were consistent across each bacteria. Disc diffusion found significance within the first antagonistic treatment for E. coli, while S. aureus found significance within the second antagonistic treatment when compared to the positive control of 25 micrograms per ml, suggesting that the capsaicin was acting antagonistically with the antibiotic. P. aeruginosa found significance in the high capsaicin concentration as well as the first synergy and both antagonistic treatments. Interestingly, the second synergy treatment exhibited an increase in bacterial growth with P. aeruginosa, with additional colonies forming around the disc. In conclusion, capsaicin appeared to cause inhibition at high concentrations when in liquid. However, when topically applied, the results varied. Antagonistic effects were found in E. coli and S. aureus, while P. aeruginosa showed some synergy and inhibition. However, further analysis would be needed to fully explore the antimicrobial effects of capsaicin.